Sorry about that. The first thing I wanted to let you know today was that I've created this tab called Recorded Lectures. And when you click on it, I'll post the lecture. I think it only took me about half an hour to get the video up yesterday, so it'll be about the same today. I'll post the recording here, and then also you can see I attached the PowerPoint that I used with all my notes scribbled in there. So if you miss anything in class, you'll be able to go back and look over my notes and stuff and watch the recording. That being said, you should definitely pay attention and take notes as we go. The other thing here, let's see, course content. I've opened up the week 2 tab, and you can see I have all the lectures posted for next week that I'm going to use, so you can download and have those handy. There is one just announcement, one change to the syllabus. I had the first homework. It was set to be due next Thursday, the 4th, but I'm going to move it to be due Sunday, the 7th, to give you a few extra days to work on it, just because we're like 30 minutes behind where I normally plan to be teaching this course. So I'm going to have to go into Thursday a little bit teaching some of the topics. So I just wanted to give you a few extra days. How many people, just out of curiosity, have looked and downloaded the homework so far?
I have.
I did.
Yeah, you'll be able to actually do most of it today, after class today, depending on how far we get. But starting next week, what I'll do is I'll open up class with ask people if they have any questions on the homework. So definitely this weekend, take a look at the first homework assignment, and you'll be able to, I hope by the end of class today, you'll be able to answer questions 1, 2, 3, most of question 3, and then hopefully question 5. That's my hope today. And then on Thursday, and then next week, we'll talk about how you do question 4, which is actually pretty easy. Okay. Otherwise, before I get started, does anybody have any questions? Let's see. Sorry, I had the chat closed. Any questions? Yep, I started the recording. Yep, we're good. Don't worry about it. Does anybody have any other questions for me? Yeah, you're welcome. You're welcome. When I'm recording, you guys should see something on your screen, right? That says I'm recording. I think maybe like down in the corner of it or something. Yeah.
On the top left.
Okay. Yeah. So if you ever notice I start lecturing and don't say anything and don't have that going, just let me know. You know, I'm a forgetful person, honestly. So, you know, having an extra set of eyes always helps. All right, no other questions? Okay, let's hop into it. So I think last class on Tuesday during our first class, we ended talking about this example about a poll and sample size versus population size. Does that ring a bell? This is where we started? Good. Thanks. Okay. So what we want to do now, if you remember last class, what I said about statistics is this class is all about data. Okay. You know, how you analyze data, how you work with data. And so not all data is treated the same. Okay. So not all data the same. So there's different types of data types. So in this next section here, what I want to talk about is how you classify data. And it's really important to understand what type of data you're working with, because that kind of sets the methods or the procedures you use to analyze it. Okay, so classifying data. So the first type of way you classify data falls into one of these two categories, okay? You can have qualitative data. So data can be qualitative or it can be quantitative. Okay, so qualitative data allows for classification of individuals based on some attribute or characteristic they have, okay? And quantitative data provides numerical measures of the individual, okay? Can anybody think of like a category or attribute we could assign to everybody or like divide the class up by?
Gender.
Sure. My wife would tell me that gender is a spectrum though, right? But so you would think of like gender or sex, you could break people up by. What else? What else could you categories? Those are great categories. What's another one?
Hair color.
Hair color. Sure. I'll turn on my video just for a second. That's okay. Don't worry about being late, Robert. It's not a big deal.
On the day.
I was wondering where you were, Robert, when I looked at the course list, but I'm glad you're with us. So like hair color, right? You guys can all see my video here. Like I belong to the category of people who have brown colored hair, right? Like that's a category we can break people into. So hold on, let's talk about that. So the next one is quantitative variable, right? So quantitative variables are variables that provide numerical measures of individuals. So Kayla had a question mark in here about age. Now, does age seem like a category you fit into or a numerical measure about people?
Numerical.
Yeah. Yeah, so this is the type of first initial analysis we do of data. So data, when you collect it, you can go, it's qualitative or quantitative. Can anybody give another example of a quantitative variable?
Height.
Sure. Yeah, height's a good one. Height. Yeah. All right, so let me go through the slides and give you some other examples. So here are some examples of qualitative variables. Your eye color, your brown, blue, hazel, green, etc. Smoking status, smoker, non-smoker, attitudes towards death penalty, strongly disagree, neutral, agree, strongly agree, things like that. So these are categories you fit into. All right, these are examples of quantitative data then. These are these numerical measures. So this is exactly kind of like we were talking about with age there. Like your pulse rate is a numerical measure. Someone also said height. That was a good one too. Exam marks, size, doesn't even have to be about people, right? Like a size of a bicycle frame is a numerical measure. Time to complete a statistics test, number of cigarettes smoked in a day. These are all numerical measures of people. All right. Let me ask you just a quick question before I get into the next one. Is this variable people's zip code? Is it quantitative or is it qualitative or quantitative?
It'd be quantitative, right?
Can I say both?
So hold on. This is where it gets a little confusing, right? So the variables, the zip code. Is zip code a numerical value though?
No.
Sure. Like my zip code is
It
07960. It's a number.
It is.
Okay.
But it's
And it keeps increasing.
Sure. Does anybody, okay, so I see some people kind of in the chat are saying it's qualitative, but so it's a numerical number, right? So like, why would you say it's qualitative though? Saying both, okay. It's location based, okay. So here's the thing, you don't ever want to say it's both. So what you want to do is you want to say things are like, it's either qualitative or quantitative. So I'm going to attempt to draw something and it's going to be terrible, but hopefully you guys can see what I'm drawing on the screen here. Does anybody know what I just attempted to draw? It's a state.
Florida.
California.
No, not Florida.
California.
No. Oh God, this is bad. This is terrible. Okay, I guess. Thank you, Brianna. I attempted to draw New Jersey. It looks like a sock here, but it's bad. Okay. So I live in Morristown, New Jersey, which is in northern New Jersey. So it's kind of like right here. And I belong to the category of people who live in Morristown. And everybody who lives in Morristown gets this identifier, 07960. Okay, so even though it's a number, those who said it was qualitative are actually correct on this one. Okay, so when you have a numerical value and you're unsure if it's qualitative or quantitative, what you'll want to do is take the average. And if the average is a meaningful number, then it's quantitative. If the average is not meaningful, it's qualitative. Like here's another one. Your student ID number. Is that qualitative or quantitative?
Qualitative.
Yeah, but like, does everybody get a unique one though? Hopefully, right? Hopefully
Yeah.
everyone's student ID number is unique. So it's actually a qualitative variable, right? But it's just that everybody falls into the category of, each category is a size of 1. So like if you were to take the average student ID number, it would be meaningless. If you were to take the average zip code in the United States, what would it be? 55555, it would be meaningless. But things like the average height of people, the average age, the average exam mark, these things make sense. So that's how when you have a number, you could tell the difference between qualitative and quantitative. Does that kind of make sense?
Yeah.
Yes, it does.
All right, good, because I'll always ask a trick question on the first exam like this, so just remember it. Okay. All right, so moving on real quick. For this class, we're just going to leave qualitative data as qualitative data. If you're interested in the textbook, they dig into it a little bit more about ordinal and nominal qualitative data, but I'll let you dig into that on your own. What I want to talk to now is about quantitative data can actually be classified even further. Okay, so quantitative data can then be classified as what we call discrete data or continuous. Okay, so let me just go back for 1 second. Looking at this chart here, data is either qualitative or quantitative. And then data can then either be discrete. Quantitative data can be discrete or continuous. All right, 1 sec. I'm bad. You guys ever like, I forgot to put my phone on silence and then get a text and feel like you have to answer it? Does that ever happen to people?
Yeah.
Sorry about it. I was a bad teacher just then, so forgive me. I know, I'm sorry, Melissa. It was incredibly unprofessional, but at least I'm being honest. You know, I'm not trying to hide it. Okay. So once you know that data is quantitative, you can then go on and classify it either as discrete data or variable or continuous variable. And if you remember from yesterday, I said, you know, section 3 of the class talks about discrete variables. Or I said yesterday, I mean Tuesday, section 3 of the class. And then section 4 of the class talks about continuous variables. So these concepts are important to understand the difference now, and then we're going to spend a lot of time talking about how you analyze them in later sections. So a discrete variable or discrete data is a quantitative variable that has either a finite number of possible outcomes, possible values, or a countable number of possible values. So in mathematics, there's actually something called infinitely countable. Like if I were to count the whole numbers, I would be counting forever. 1, 2, 3, 4, 5, but I could count them. Okay, so basically discrete variables, think of these as counts of some type. So continuous variables or continuous data is a quantitative variable that has an infinite number of possible values that is not countable. So continuous variables actually tend to be measurements of some type. Yep, I'm going to give you a bunch of examples, Robert. Don't worry. So let me jump into. You're more than welcome. There'll be very rarely in this class where I introduce something and then don't give an example. So I'll always follow it up with it. You don't need to worry about that. Let's see. So some examples of discrete. So these are counts. Okay. Number of children in a family, number of students passing exam, number of crimes reported to police, number of bikes sold in a day. It's like you're just counting the number of these things. Okay. Here's another example, or another way of telling if it's discrete. Another way, if you're unsure, generally, if you know the next possible value that could happen, it's a discrete problem or a discrete variable. So something where so yes, Melissa, absolutely. But remember, it can also be infinitely countable. But generally, there is a limit to how many things there could be. Like this would be a good one. So I have one child. If I have another child, how many children will I now have?
2.
Yeah. So like it's such a silly example, but like number of children, how I know it's discrete is I know the next possible value. If somebody has one child, they have another, the second one is their second one. Like we wouldn't say if I have one child, then I have half a child next. Like I wouldn't say he has 1.5 children in his house. That doesn't make sense. Okay. All counts of some type. These are examples of continuous data where these are measurements. So height, how tall somebody is, that's a measurement. Time to run 500 meters, that's a measurement. The temperature outside, right, that's a measurement. Like if I were to tell you, so these are all measurements. If I were to tell you all that I am 5.8 feet tall, okay. How tall is the next person? Like, do you know what I mean? Like, you can't say, like, is it 5.9? Is it 5.81? Is it 5.8001? Like, there's no way to know what the next possible value is. Okay, so that's my other trick. So I know what the next possible value is, or it's a count, discrete. Measurement, I don't know what the next possible value is. That's continuous. All right, makes a little sense?
Oh, I'm sorry. So how is height if once you reach your height, how is it continuous?
If you think of all the people in the world, right?
Okay.
That now makes sense what I mean by the next possible value.
Gotcha.
Okay, good. All right, let's do these. Don't cheat and look at I think I have the answers on the next slide. Don't look at them. All right. It just helps us to see this. So I've got these 8 variables here. Okay. And I want to classify them either as discrete or continuous. Okay. So I want us to just, as a class, I'm going to pause for a second. And on your own, just think in your head. Okay. Starting with cups of coffee consumed in a day and then going clockwise. Would you classify these things as discrete or continuous? I'll give you 20 seconds to think about it. Okay. Yep, I'm going to ask you. We'll go one at a time. So we'll start with this one, cups of coffee. One thing you'll learn about me, I'll put my video on real quick, is that I love coffee, okay? I drink probably a pot a day. Can't help it. So a lot of times when you hear me pause and go like, it's because I'm drinking my coffee. But cups of coffee consumed in a day, is that discrete or continuous? Yep. Yeah, I agree. Right? It's a count. So Melissa and Beatrice have it, right? It's a count, right? Like I'm counting the number of cups of coffees I have in a day. Like I have 1 cup or 2 cups or 3 cups. You know, it's blasphemy to have half a cup. So it's a count. So like if I have 1 cup of coffee and then I have another one, how many cups would I have? So like you're counting, so you know the next possible value. Like look at this one here. Volume of a cereal box. Is that a measurement or a count or a count? So is it discrete or continuous? There's a bunch of different answers there, but yeah. So volume is a measurement of something, right? It's a measurement of the mass. So this is continuous. How about the speed of a car? Is it a measurement or a count? Yep, you guys got it. It's continuous. Population of a town, discrete or continuous? Is it a, yep, so 2 different answers there, but so is population of a town a count? It's a count, right? Like how many people live there? Yeah. Yep. Length of a crocodile.
Continuous.
That's weird. Someone just said it, yeah. Continuous, yeah, it's a measurement, exactly. Number of matches in a box?
Discrete.
Yeah. Yep, it's a count. Temperature of an oven?
Continuous.
Yep.
Continuous.
Yep.
I finally got one.
And how about the number of goals in, we'll say, a hockey season? Yeah, it's a count. Yep. So just counts measurements. Okay. Go Rangers. Yes. Although I'm a Devils fan in New Jersey. Although I'm not really a hockey fan, so I don't know why I said that. But if I had to pick a team, it'd be the Devils. Okay. So I got the answers here for you too. And don't worry, as the course goes on, we'll get more, we'll deal with more data, and as you see more stuff and you see more examples, it'll become more concrete for you. Okay. All right. What I want to talk about now is sampling methods. And what this is methods for collecting data. And I'm going to talk about 4 of the most common methods for collecting data in the real world. Okay, so how data might be collected by professional statisticians, and also the most common ways. Okay, the 4 types of sampling we're going to talk about is simple random sampling, stratified sampling, cluster sampling, and systematic sampling. The most important one is this one, simple random sampling. Okay. It's incredibly easy to understand this concept of simple random sampling. And what you'll notice is that as we go through the class, most advanced theories or theorems of statistics will require a simple random sample. A lot of the theorems in the class will say something like this. If you have a simple random sample, you can conclude the following thing. The other sampling methods we have is because oftentimes simple random sampling is like really hard in the real world. And I'll talk about that a little bit. So statisticians come up with other methods of sampling these stratified, cluster, and systematic. So these are also just as fine. They're just not the best method. Okay. So let's start with simple random sampling. So a simple random sample is a procedure in which each member of the population is chosen strictly by chance, okay? And each member of the population is equally likely to be chosen, okay? So for example, if you're called for a survey and it's done through simple random sampling, you know, if you were picked, it was just by chance. They didn't like zero you out. And then also you were just as likely to be called as I was likely to be called, okay? And this resulting sample is just called a random sample, okay? I like to think about it as if you draw names from a hat, okay? Everybody has a chance to be picked, okay? So most statisticians and most survey researchers really try to do a simple random sample. Like they just want to call people on the phone for a survey and get them to answer. If they dial my number or your number, it was just by chance, okay? Problem is with this is getting a simple random sample or getting a truly random sample is often really hard in the real world. Okay, let's just take the, I'm just curious, did anybody get called for a political poll this last election cycle? Okay, Melissa did, yep. I'm just curious, Melissa, did you answer the poll?
Yes, I did.
You
I
did?
did, but that's not normal for me to answer an unknown call.
Sure. And they've gotten a little bit better on your cell phones. A lot of times, some of them actually are starting to have identifiers, like they'll say X research firm. But so here's the problem with it, right? So they're going to call people at random. Okay. What do you think most people do when they get a call? And I think, I don't know if that was you who answered, Melissa, but what do you think most people do when they see this number, this unknown number on their phone?
Ignore it.
They ignore it or don't answer it, right? So all of a sudden now what you have here is you're trying to get this random sample, okay? And tons and tons of people don't pick up the phone, okay? So now all of a sudden you're introducing like a little bit of bias in your results, because now your results are biased towards people in the population who have a tendency to pick up the phone and then answer the survey. So it's like, are people in the general population who pick up the phone and then answer a survey different from the general population as a whole? Maybe not, you know? So like this random sample is really, really tough. It's really, really tough. Yeah, so my wife is a survey researcher. So we, you know, as a matter of professional courtesy, we answer all the polls. And I live in a somewhat competitive district, so it was really interesting to follow. Okay, so simple random sampling, really hard in the real world. So there's some other methods here, okay? One is called a stratified sample. So a stratified sample is obtained by separating the population into non-overlapping groups and then obtaining a simple random sample from each group, okay? So the individuals within each, what they call stratum or group, should be similar in some way. Okay, so let me give you an example of how this might be done in the real world, okay? Suppose I'm going to draw something. You tell me if I do a better job here. What did I do a better job of drawing here? That is New York. Yeah, much better.
New York.
Much better. All right, suppose you want to survey people in New York, okay? And you want to get like just a general overview of everyone in the state, okay? So you want to make sure you sample people from every region in New York State. So how could you divide New York State into non-overlapping regions? Like everybody lives in it's a C word, a different, yep, by county. That's it. Yep. So like this might be the counties. I don't know, you know, what the counties look like. I used to live actually in New York. I lived in Saratoga County growing up, actually. So this is what you're doing. So what you would do is you take the population and divide them into non-overlapping groups. Okay, so by county. And then you would randomly sample people within each county. So you get a small number of people from each county. So then sample from within each county. Right, that would be an example of a stratified sample. You could do it. If they wanted to get a survey from college students, they could separate the population non-overlapping classes by like separating everybody into the 11 o'clock classes and then sampling a few people from each class. Like this is just a way to make sure that you have a representative sample from a lot of different areas. Okay. Let me move into a cluster sample, and then I'll give you an example of a real world cluster sample. Okay. So a cluster sample is obtained by selecting all individuals within a randomly selected collection or group of individuals. Okay. So here's kind of just the idea here. You imagine all these dots represent the population. Okay. And each colored dot is a different segment of the population. So instead of calling dots at random, I know that sounds silly to call dots at random. What you do with cluster sampling is you say, okay, this is one cluster, this is one cluster, this is one cluster, this is one cluster, this is one cluster. Instead of randomly sampling from each cluster, you just say randomly select and say, I'll take all of these dots to form my sample and all of these dots to form my sample. Okay. And you pull these together, and these two groups together is called your cluster sample. So it seems weird. Like, why would you do that, right? Let me give you an example. This happened to me actually a number of years ago. Do you guys remember when we were like allowed to fly with unabandoned freedom before COVID? That was a bad joke. Yes, I'm sorry. You got to forgive me. I used to fly. I did not a lot, but I would fly 6, 7, 8 times a year, and so I kind of miss it. But anyways, so I was flying in this airline company called Southwest. Have you guys heard of Southwest before?
Of course.
Yeah. I call them the Greyhound of the sky. Okay, that's my joke. But I used to love flying from Southwest, mostly because there were no assigned seats. But anyways, I digress here. So a number of years ago, I was on a Southwest flight, and this is a true story. I'm not making this up. The flight attendant goes onto the mic, and here, I don't remember if it was a he or she, but here she said, hey everyone, we have a customer satisfaction survey we'd like you to complete. Would you please complete it? And then they literally went to every single person on the plane and gave them a survey, and it was a Scantron. They gave everyone the survey and the number 2 pencil, and they said, fill this out. Okay. And I remember being like, what is going on here? And, it's just a normal survey with normal questions like, how was your beverage service? How was your bag service? Was your flight on time? All that stuff. And so I remember there was like a number, like, oh, if you want more information about the survey, please fill it. Please call this number. So I was legit curious. So I don't even remember where I was going. I got to my destination. I called the number, and I was like, what the heck was going on with this? And they were like, oh yeah, we did. They explained the sampling method to me, and I was like, oh my gosh, that's cluster sampling. So what they wanted to do was, instead of randomly selecting just any old passengers, they took their population and divided it into non-overlapping groups. And each non-overlapping group was the planes in the air. So like, for example, what I mean is, could you be in 2 airplanes at once? No, right. So they took all the airplanes in the air. Okay. And so I'm just going to put, this is plane 1. This is a really bad plane. This is plane 2. This is plane 3. I don't know, it was Southwest at the time. They probably had 1,000 planes or a couple hundred planes in the air. Actually, I don't even know what the guess would be. We'll just say plane 100. And what they did was they said, okay, let's give this survey to, and they randomly said, let's give it to everybody on plane 2 and everybody on plane 100. And they pulled all these together, and that was your cluster sample. So that was an example. That's how they did it in the real world, and I was incredibly interested to learn about that. All right, make a little bit of sense about this cluster sampling.
Yeah.
Yes.
Okay. All right, the last sampling method is called systematic sampling. And this is obtained by selecting every kth individual or object from a population. So like what this would be an example of, and I'll give you a fake example then a real world example. Suppose you wanted to sample every adult in the United States and ask them what their opinion is on taking a statistics course, okay? Everyone would say they love taking statistics, correct?
Of course.
Obviously, yep. So what a systematic sample would be is you would select every third person, okay, every kth. So this kth time, my kth is 3. So you would select the third person. Then you go 1, 2, 3. Then you'd select the 6th person. And then you'd select the 9th person. And so on and so on and so on. All right, but like you can't line everybody up in the real world. So let me give you an example of a systematic sample. So I didn't always used to be a teacher. Okay, I've had a number of real world jobs, but my first real world job, I worked for this company, and we were charged with analyzing potential Superfund sites. Okay. Does anybody know what a Superfund site is? Just out of curiosity.
No.
Yes.
What's a Superfund site?
Gowanus Canal.
But what is it that makes it a Superfund site? That's okay. Huh? Yeah. So
Has to clean up the mess.
yes, so that's exactly it. So Superfund sites are sites that are designated by the EPA to have a high level of environmental contamination, right? So like there are literally thousands and thousands of Superfund sites in the United States. If you Google your address, you probably, everyone here probably lives within a couple 100 miles of a Superfund site, okay? So we were tasked with determining if this river met, the requirements to be a Superfund site. So what we had to do was we had to sample, water, take water samples along the river. And we did it with a systematic sample. We got here, we took a sample here, then we went 1,000 yards, took another sample here, then we went 1,000 yards, another sample, 1,000 yards, another one, 1,000 yards. So we did the sampling in a systematic way. Okay, here's where it was done every 1,000th yard is what we did here. Okay. So here's just a chart for you. I'm not going to go over it, but it just as another way to see the 4 different methods here, just visually for you. Okay, I want to end talking about errors in sampling. And this is what I love, cluster. So the cluster right here, Jamie, is that what you're asking? So yeah, all you're doing is you're saying, okay, I'm going to divide the population up into non-overlapping groups. Okay, like for example, I live in Morristown, right? And so say they wanted to, the mayor of Morristown wanted to conduct a survey. Okay, so what he would do for a cluster sample, Morristown, let's just say Morristown looks like this. Okay. Morristown is divided into 8 wards. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So if you wanted to, the mayor, it's a gentleman, if he wanted to sample individuals and using a cluster sample, what he might do is say, oh, you know what, sample everybody in the 1st ward and everybody in the 8th ward. And those 2 groups together will form my cluster sample. Does that make sense, Jamie?
Yes, thank you.
Yep, no problem. All right. Errors in sampling. The reason I really like gravitated towards studying statistics and why I think it's really interesting is sometimes statisticians just like don't get it right. Okay. And it's not that they perform a bad analysis or perform the methods we even talk about in this class. Sometimes statistics just gets it wrong. A lot of times you'll hear me talk in this class later on. We'll form something called like 95% confidence intervals, or our level of significance will be 5%. So if I say something like I'm 95% confident, okay, how often do you think that means I might be wrong in my results?
Another 10%.
And if I'm 95%, I'll be
5%.
5% wrong. So I'll be wrong 5% of the time. So look, that's just really cool, right? Like in statisticians are like, oh, look, I'm only 95% right. So sometimes you'll get it wrong. And generally, there are errors in statistics and our conclusions in sampling because of the following reasons. Okay, so first, we use a sample to estimate for a population. And sometimes the sample gets it wrong, okay? And the reason is there's errors in your sample, and they result either from what are called non-sampling errors or sampling errors. Okay, so non-sampling errors, these are things we try to control for. So these are errors that result from the survey process. So they're due to non-responses of individuals. Like, for example, we just had the census, right? Hopefully everybody filled out their census. But like, if you don't fill out your census, generally what happens?
And the numbers are off.
Well, yeah, but what do they try to do though? They knock on your door 400 times. Melissa has it right. Maybe it was reduced because of COVID this year, but like that's non-responses, right? So you try to control for this, okay? You can try to help with poorly worded questions. Inaccurate responses is a tough one to control for. Like here's an example. A few years ago, I was selected for the community housing survey. I'm not sure if anybody has heard of that, the community housing survey. But it's just a survey done by the government. And like, they just ask you a bunch of random questions. And one of the questions they ask is like, what is your yearly income? And if I say something like, I make $1 million a year, all right, that's an inaccurate response, right? So that to the best of the ability to try to control for that. Sampling errors. And these are a little bit of issues you might not be able to control for. So these are errors that result from using sampling to estimate information regarding a population. Right? This type of error occurs because a sample gives incomplete or inaccurate, I'll say that, incomplete or inaccurate information about the population. So let me give you an example of this. Suppose someone wants to conduct a survey and they want to estimate the average income in the United States. And so what they do is they call or sample 30 people. Okay, and there's actually nothing wrong with just calling 30 people. Okay, that's not necessarily a poor sample size. And so the first 29 people they call are people who just have normal jobs: teacher, firefighter, nurses, daycare worker, garbage men, firefighters, Amazon truck drivers, things like that, okay? And then the 30th person they called is the richest person in the world. Does anyone know who the richest person in the world is right now?
Elon
Musk. Yeah. Thanks to his Tesla stock. Elon Musk is the richest person in the world. And so imagine that the 30th person they call is Elon Musk, okay? And they say, all right, let's take the average income of those 30 people. Do you think that average is really reflective of the mean? Yeah, no, it's not. It's going to be way skewed. And it's not like you did anything wrong. It's just that you called Elon Musk and it just warps your results. Okay. And so that's what when we talk about sometimes when you hear me say things like I'm 95% confident, it's because you can never be 100% sure with your sample. It's just unrealistic to be. All right. Data, sampling, all that kind of stuff makes sense. Interesting a little bit. Yeah, and we learned, if you didn't know, Elon Musk was the richest person in the world. All right. So let me just. So what I want to do now, let's see, we started here. So what I want to do now is I want to switch over to the second lecture. So I'm going to save this and I'm going to put it to the classroom so that you guys can have it with my scribbly notes. So what I'll do is I'm going to post this here, the recorded lectures. And let's see. So I've been lecturing for about 50 minutes. So if you guys remember, I think I said we'll take a break after about 50 minutes. Do you all remember that?
Yeah. Yes, you said so.
Yeah.
Okay. So what we'll do now is it's 1:48. Let's start back at 1:55. Okay. So we'll start back up at 1:55. So take a quick 7-minute break, go grab a cup of coffee or the bathroom or whatever you need to do. And I'll be back in a little bit. Sound good, everybody?
Yes.
Yep.
All right, can everybody hear me okay?
Yep.
Okay. All right, so what we want to do now is we want to talk about, we've talked kind of like in general about statistics and sampling and data. And what we want to do now is we want to talk about ways that you begin to take raw data and you organize and summarize it. So the first things we're going to talk about is visual ways to summarize data. And if you notice, if you look at this PowerPoint slide that I have, it's 50 slides. We're not going to get through it all today. We are actually going to go through it really quickly because a lot of it's pretty easy stuff. And I guess what I'm kind of just trying to hint at is it's a little dry.
Thank you for the.
You're welcome. I'm just, so just bear with me with it. A lot of it's pretty straightforward stuff. So just bear with me while I get through it because a lot of these graphs and stuff come up throughout the rest of class. So it's just really important to understand how to construct them. And then what we'll do next week is we'll start talking about numerical ways to summarize data. And what you're going to need starting next week is you're going to need your TI calculator. Okay, so make sure you have your TI-83 or TI-84 calculator because what we'll start doing is we'll start just doing some menial calculations and we'll use our calculator for that. And then some of the harder stuff, what I'll do is I'll show you how to do it once by hand and then I'll show you how we'll do it on your calculator going forward. So just make sure you have that handy because as we go through the lectures, it's just great to have it, right next to you while I'm talking about this stuff and following along. All right, so the first thing we want to talk about is how you organize qualitative data. Okay, so this is categorical data. Okay. And what we're going to be talking a lot about are these things called frequency distributions. Okay, so or this concept of frequency. So what we're going to do is to set the stage, we begin with some definitions. Okay, so this is the key concept for this lecture, for this concept of frequency. Yeah, I can go back a moment, no problem. Gives me a chance to pause and have a sip of coffee. I don't know about you all, but I don't know how people survive without coffee.
How do you take it?
Just black, the way it was intended. No problem. I don't know how you survive without coffee. You know what? I'll be honest with you. I didn't start drinking coffee until I got my first job out of college and had to get up early. I guess that's what did me in. All right, so frequency. So this is the key concept of this section. So to set the stage, we begin with some definitions. So we're going to take our data, and what we want to do is we want to talk about and divide it up into what we call a class. So a class is one of the categories into which data is classified. So think of the class that we're going to put data into. Think of this as the group or groupings for data. Okay, so we want to take our data, raw data, and put it into different classes or groups. And then all frequency is the number of observations in the data set falling into that particular class or group. So all a frequency really is frequency is a count of some type. So just counts by themselves aren't really useful. So we developed this thing called a relative frequency. And the relative frequency is the class divided by the total number of observations in the data set. Okay, so think of relative frequency. What this is a percentage or proportion of data that falls into each class. Okay, So we're gonna break the data up into different classes. Frequency is just the count of each. And then this concept of relative frequency is just the class divided by the total number of observations in the data set, which is really just the proportion of data that falls into each class. And don't worry, we're gonna do a bunch of examples of this stuff, so don't stress too much about it. All right, so then we're gonna put this all together in what's called a frequency distribution. And a frequency distribution of qualitative data is a listing of distinct values, okay, and their frequencies. So really what you're gonna have here is the classes or groups. And then right next to it, you're gonna have the frequency or the counts. Yep, I can go back, no problem. I have a tendency to go really fast on this stuff, Jamie. So if you need me to slow down, let me know. No problem. Are you good?
Well, 1 second.
Yep. One of the things I noticed with remote learning is that, yeah, no problem. One of the things I've noticed with remote learning is like, it's just so easy to just go because I don't see everybody's faces all the time, you know? So forgive me for going too fast sometimes.
All good.
Take a picture. I don't also remember I post these slides. So if you miss something that I'm writing, you know, you can always go back to it. All right, so a frequency distribution, what it's going to be is it's going to be just a table actually. And what the table is going to show is it's going to show the data groups or classes, and then the counts of each. Okay. So what I'm going to do is I'm going to burn through a quick example that's in the slides, and then as a group, we'll do an example all together. Okay. So don't stress too much as I burn through the slides. Pay more attention when I get to the first example that we're going to do as a class. All right, so here's an example. So suppose you were to ask students their political party affiliation of students in an introductory statistics course. So imagine I just took a class and I just said, you know, what is your political party? And again, I'm sorry, this is political in nature, but I don't ever want to talk politics at all. So we'll just take this data as is, okay? So I've got these groups here, okay? So just by looking at the data here, what are the categories or classes that people fit into? Or groups? What I mean by that, what are the 3 political parties that are listed here?
Republican,
Yep, you could break people up as Democrats, or Republicans,
other.
or other, right? Okay. So this is what I mean by classes. So I want to take this like raw data and I want to put it into a frequency table now, or frequency distribution. All right, so the procedure for creating this frequency distribution is super straightforward. First thing you're going to do on your table is you're going to list all the distinct values of the observation in the data set in the first column of the table. Okay, so you're going to have your classes. So you got your Dems, your Republicans, and you got your other. And then what you're going to do is for each observation, you're going to place a tally mark in the second column, all right, in the table of the row, in the row of the appropriate distinct value. So if you were to count this by hand, what you do is you'd go back into this table and you say, okay, here's a Democrat. You put a tally mark. Then you go to the next person. They're Republican. So then you put 3 tally marks, and so on and so on. And then all you would do is you'd count the tally marks to get your frequency. So I'm not going to do this by hand here, but you can see this is what it comes out to be. Okay. So just from this, you know, obviously made up data. Okay. There were 13 Democrats in the class. There were 18 Republicans. And there were 9 people who said I belong to an other party, you know, like libertarian or the rent is too damn high party, if you remember that guy. So that's how you would do this by hand. Pirate party, sure. So it's also one thing to just like, if I were to go to my department meeting and I were to say, oh, hey, you know, I took this class, or in my class, there were 9 people who said they belong to an other political party. There's no context behind that number because it's like, well, is it a class of 1,000 students? Is it a class of 50 students? You know? So what we do next is we do this thing called this relative frequency. Okay. And all the relative frequency distribution or relative frequency distribution of the table is it's a listing of the distinct values and their relative frequencies. So instead of reporting frequencies, we report the proportion or percentage, if you want to change it to a percentage. Would you still use that data or maybe read it? So just give me 1 second, portion or percent. So it depends, right? Like if I were to, this isn't about sampling. Okay, this is just my data. This is just how do I summarize the data? Just for a little bit inside baseball, if you're interested, what statisticians and what survey researchers really do in the real world is when they get a survey, generally what they do is they take the results and they don't just like report them as is, like trying to give a good example. I hope this is okay to say, you know, please forgive me if I don't mean to offend anybody, but suppose a survey researcher surveys a population and within that population, 60% of the population is Caucasian, okay? But they take their sample and it comes back that 70% of the people who responded to the survey are Caucasian. What they'll do is they'll weight the data down to only count those responses 60% of the results. So like they try to fix for things like what you're hinting at there. Does that make sense to answer your question there, Melissa? Okay, so let's just go back to this. So let's obtain a frequency distribution of the data. So to do this, you're just going to divide each frequency by the total number of observations. That's just how you get a percentage or a proportion. So in this example here, the relative frequency table or the relative frequency distribution, you would just take the individual counts and divide that by the total. That's all you did. So you took the 13 Democrats, divided it by the 40 people in the class. You can see that that class ended up being roughly 32.5% Democrat. There were 18 Republicans. So that comes back, they were roughly 45% of the class is Republican. And then 22.5% when you take the 9 divided by 40, came back to be other. When you go to do your homework, the most important thing that you have to do with the relative frequency is you have to make sure they sum to 1. Okay, because they have to represent 100% of things. When you go to do your homework and you start rounding things, it's okay to fudge your numbers a little. So like if you round something up, you can just round something down to balance it out. But just make sure that your relative frequency tables sum to 1. Okay, visual representations of this frequency distributions. So what we want to do now is we want to take our frequency tables and show them visually. Okay, how many people, just real quick, have heard of pie and bar charts before?
Yeah.
Yeah, I mean, do you see these basically every day in the real world? Like when you look at news articles or just you open up a textbook, they show pie and bar charts. Yeah, I hope that you've all seen them before, right? Okay, so let me just go through a pie chart real quick. I'm just going to talk about how you make it. We're actually never going to make one in class, but just in case. So a pie chart is a disk divided into wedge-shaped pieces proportional to the relative frequency of the qualitative data. So let me even just skip this and just show you what it looks like. So this is the pie chart for the political parties of that class, okay? And all you did was you took your circle and 45% of the area of the circle, which corresponds to the relative frequency, you shade with Republican. The 32.5%, so 32.5% of the area, you shade with Democrat. And then the 22.5 for other, you just shade a different color here. The good news is if you take another class and you use a program like Microsoft Excel, they just do this stuff for you. But that's really what's going on behind the scenes. They're like, okay, 45% of the class is Republican, 45% of the area of the pie or the circle needs to be Republican. Okay, a bar chart. I'll ask you to do this. This and the corresponding feature called a histogram will come up on your homework. So a bar chart displays the distinct values of qualitative data on the horizontal axis and the relative frequencies or percents, which one you want of the values on the vertical axis. So what a bar chart does is a bar chart along the horizontal axis is going to display the classes. And then along the vertical axis up here, what it displays are however you want to do it. You can do frequencies or relative frequency. Okay. And the big thing about bar charts, and I'll do a silly example in a little bit to illustrate this. Bar charts should be positioned so that they do not touch each other. Okay, so the bars do not touch. Okay, and we leave a space between the bars when you construct a bar chart to illustrate that there's definite differences between the classes. All right, so basically what you're doing, and sorry for the little bit of an overlap there, is you're going to obtain the relative frequency distribution of the data. Okay, that's applied in it says procedure 2.2 there, but it's just previously how you had done it. And then you're going to just draw the horizontal axis on which to place the bars and a vertical axis on which to place the relative frequencies or frequencies. Okay, so for each distinct value, construct a vertical bar whose height equals the relative frequency of the value. And then you're just going to label the bars with distinct values. And the horizontal axis with the name of the variable and the vertical axis with relative frequency or frequency. So what a bar chart would look like for the political example. So along the horizontal axis, you're going to put your classes. Okay, so these were the groups, right? So there were Democrats, the Republicans, and the other. And then along the vertical axis here, this one here is going to be a relative frequency. So if you remember the Democrats, oh gosh, I think we're 32.5%. The Republicans were 45%. And the other were 22.5%. And you notice what you did was you drew your bar up to 32.5%. The Republicans went up to 45%. And the other you went up to 22.5%. And the reason with bar charts you have spaces between the groups, would you agree that there are, I guess this is like a Harper partisan time, but do you believe that there are differences in the political parties, like Democrats and Republicans and people of other parties have different philosophies that they subscribe to?
Yes.
Yep,
Yeah.
totally, right? I'm not saying one's better than the other, I'm not saying that. But all you're gonna say then is once you draw your Democrat bar, you're going to leave a space for your Republicans because there's definite differences between them, and the same with the other. Okay. I want us to do one example where we use our class and we do this by hand. So just so you can see how to do this, okay? I'm a little bit of a sports guy. I'm actually a really big baseball fan. So when baseball season comes around, if anyone wants to talk baseball, I could talk hours about baseball. But what's coming up? Yeah, love the Yankees. Who doesn't love the Yankees? What big championship is coming up in a couple weeks?
Super Bowl.
The Super Bowl. Who's playing in the Super Bowl?
The Buccaneers and the Chiefs.
Buccaneers and Chiefs. Okay. And so what I want us to do is I want us to collect some data here. So unfortunately, I need everybody in class, and I guess we'll find out who's still paying attention. Everybody to participate in this. Okay. So I'm going to launch a poll. Does everybody see the poll that went up?
Yeah.
Yes.
Okay. So here's my question. Who are you rooting for in the Super Bowl? You got to pick. Okay. So you can pick the Buccaneers, the Chiefs, or you can say neither. Okay. If you neither apply, if you're not going to watch, you don't care, the neither is the capture all. Okay. So I'll give you a couple seconds to think about it. So hopefully everybody participates. We're at 21 people participating so far, 22. I'll give it another couple seconds to let people. We're almost at 100%, which is great. All right, looks like we're ending there. So let me show you the results, okay? Everybody see the results that we got?
Yes.
Okay, so it looks like here. So what I want to do is I want to take this data now, and what I want to do is I want to put it into a frequency table, and then I want to construct I want to find the relative frequency too, and then I want to construct a bar chart for it. Okay. So these are the classes that you fit into. And I'm going to join the fray here and tell you who I'm rooting for, okay? So the classes, we either have the Bucks fans, the Chiefs, or neither. Okay, so we already got the frequency for it. These are the counts. So how many in the class are rooting for the Bucks, the Buccaneers? Does it say there? You guys see the results?
35%.
So frequency is just counts. So it looks like, do you guys see the number 9 there or no?
Oh, no.
Okay.
There's
It just says that, oh, okay, it must only show me the counts. All right, so my apologies. On my screen, it actually shows the counts. So 9 people in the class just said that they were going to root for the Buccaneers. I'm actually rooting for the Buccaneers too. Okay. I want touchdown Tommy to win. Okay. Then it said 5 people are rooting for the Chiefs. Ooh. Come on, they won last year, guys. Yeah, it should show it there. I got it. And then it says 12 people are neither. I'm just curious, for the neither people, do you just not care, or is it just like you're not interested in the Super Bowl? Don't care.
I don't understand it as a game.
Oh, it's an awesome game. I love Super Bowl. Well, usually we have a big Super Bowl party, but not this year. But yeah, I just love Super Bowl. It's fun. All right, so hopefully for the neither people, you can watch for the commercials. You should root for the Buccaneers. Touchdown Tommy. We want to win. All right, so let's count how many total people participated in this poll. You can see it's 27. So 15 plus 12 gives me 27. And then what I want to do is next is I want to find the relative frequency. All right, so to do that, what I'm going to do is I'm going to take the counts in each, the frequency in each group, and divide it by the total. So I'm just going to grab a trusty calculator that I have next to me. So if I were to take 10 and divide it by 27, I'm going to get roughly this. Did anybody else get that? Just out of curiosity.
Yes.
Yep. You take 5, you divide it by 27. All right. If you plug that into your calculator, you're going to see the number 0.185. I'm going to round this up to 0.19. And then I'm going to take 12 divided by 27. And you should get 0.44444. So I'm going to round that down. Yep, relative frequency is just the divided by the total. And what you have to do is just make sure that you round it in such a way that it sums to 1. And we did. Okay, so this sums up to 1. So we're good. Okay. Yep, relative frequency is just the count divided by the total. That's it. That's all you had to do. Now let's construct a frequency bar chart. So if you look back in the notes, in the slides, I did relative frequency. So what I want to do here is just a frequency bar chart. So it's super simple. All you're going to do is construct the first quadrant of the Cartesian plane, okay, a horizontal and vertical axis like this. Now along the horizontal axis, you're going to get your classes or your groups. So we're going to have the Bucks fans here. Then a space, okay, for the Chiefs. Okay, and then another space for the people who fall in the neither. And so when I say a frequency bar chart, we're going to use these numbers here. Okay. So I'm just going to go by twos. 2, 4, 6, 8, 10, 12. Okay, so the Bucks fans, there were 10 of them. So what I would do is I would just draw a bar up to the number 10. And those are the people who are rooting with Touchdown Tommy and those baby blue eyes with me. Okay. The Chiefs, there were 5 of them. So you're going to go up to the number 5. Boo, Patrick Mahomes, no. And I'm just going to shade it in. And then it looks like there were 12 people who were neither. And what you should do is you should just root for the Buccaneers. Okay. Mostly because I have a $5 bet with my brother and I have the Buccaneers. Okay. All right. Yes, we only play for serious money. He wanted to do $1, but I said, no, we need to get our blood pumping for this game. So we should raise it to 5. Okay. So that's how you take raw data and summarize it up. So seeing me work this example, does it, pretty straightforward and easy? Not too bad. Okay, good. All right, you'll get a chance to practice this on your homework as well. But the homework example you'll see is a little bit different. So I've got about 27 minutes left for the homework number 3. It says histogram. So that's why I said the homework is a little different. So the homework doesn't actually have to do a bar chart. It has to do with a histogram. And Jamie asked a great question, which moves us into our next topic. Okay. This is more relates to what your homework question is. Okay. And this is organizing quantitative data. Okay. So these are numerical measures. Okay. So how you handle this is a little bit differently, okay? And this is what I want to get through before class ends real quick, okay? So when you have qualitative data like the political parties that you belong to, that was easy to do. How you handle quantitative data is a little bit more tricky, okay? So here's this first example here. Suppose we just sample 50 households and we ask them, how many TV sets do you have in your house? Okay. And these are their responses. Okay. So these are the number of TVs people have in their house. So like, here's 1, someone has 1 TV, somebody has 0 TVs in their house. Somebody has 6 TVs in their house. My wife and I, we have 1. What type of data is the number of televisions you have in your house? Is it, qualitative or quantitative?
Qualitative.
Qualitative.
Is it a measurement of some type though? Like, is it a count?
Yes.
Yeah, it's quantitative. But is it quantitative, continuous, or discrete?
Discrete.
Yeah, because it's a count, right? Okay, yeah. So continuous would be we'll do a measurement of some type in a second, but it's a discrete. It's counts, right? Like for this type of data, what we don't say is you belong to the group of people who have one TV in house. We don't do that. We just say this is a count of the number of televisions you have in your house. So what we want to do is we want to take this raw data and we want to do the exact same thing we just did. We want to put it into a frequency table. Okay. So put into a frequency table. All right, so how you group your data when you have quantitative data is the most important part. Okay, so we have to take our raw data and what we have to do is we have to put it into different classes or groups. So it's up to us to put the data into different classes. And there's two types of ways you can do this. So we're going to take the data and we're going to put it into different classes. Notice how this person also has the most important thing that they would need to get through the day. But the two grouping methods we have for this is we have what's called the single value grouping. Okay, you use this with discrete data, okay, in which there are only a small number of distinct values. So if you look back here, this looks like a small number of values in its discrete data. So it looks like the only possible values are 0, 1, 2, 3, 4, 5, and 6. So there's 7 different numbers there. So this will be our first example using the single value grouping method. Then the other way you do it is with what's called limit grouping. So you use this when the data are expressed as whole numbers. We can even do it with decimals sometimes. But what happens here is there are too many distinct values to employ single value grouping. So this limit grouping, you'll notice when we get to our next example after this one, is it uses a range of values for each group. Okay, so let's do this single value grouping method first. And is everybody okay if I move on real quick? Okay. So this is the single value grouping. And what this does is this took this TV data and it just put it into a nice frequency distribution, okay? And this one showed, just like my example, the frequency and the relative frequencies next to each other. So look, we use this single value group because there was a small number of values. So here we put the different possible values. Okay, and it looks like there was 1, 2, 3, 4, 5, 6, 7 of them. And then these are the frequencies. These are just the counts. So all we did was we looked through the data and we said, okay, there was one household that had 0 TVs. There were 16 households that had 1, okay? And then all we did here for the relative frequency was you just found the count divided by the total. So like this first one here there was 1 household out of the 50 that had 0 TVs. Okay, this next one here for the relative frequencies, there were 16 households out of the 50 that had 1 TV, and then so on and so on. So this single value grouping method seems a lot like what we did with the political party one. Okay, just instead of Republicans, Democrats, and others, we just counted the number of zeros, the number of ones, and so on and so on. So pretty straightforward. I don't want to spend too much time on it. So I'll just say very similar. to the example with political party. So this is a little bit different now though, okay? This is an example with investments here, okay? So if you look here, what you have here is you have the days to maturity for 40 short-term investments, okay? So whatever these investments are, okay? You buy this investment, and then listed here is how many days till your investment goes to maturity and you can cash it out, okay? Now look at the numbers here. Do you notice how there's not that many repeats and there's a lot of distinct values here? Do you guys notice that?
Yes.
A lot of distinct values. Okay, so what would not be appropriate for this is to do the single value grouping is no good here.
So then we'll use limited.
Yep. So what we're going to do here for this type of examples, we want to use this limit grouping. So what the whole idea between limit grouping is you want to group together. I'm going to put in parentheses like values. Okay. And what I mean by like values is, maybe I could put the one that takes 62 days and the one that takes 64 days together somehow. Or maybe I can take everything in the 70s and put them together. Okay. So the procedure for this is, it seems like it's a little bit harder, but it's actually not. Okay. So these are the terms we use for limit grouping. So we use what's called a lower class limit. It's the smallest value that could go into a class. The upper class limit, it's the largest value that could go into class. We use what's called the class width. And this is the difference between the lower limit of a class and the lower limit of the next higher class. And then we use what's called a class mark, which is the average of the two class limits of a class. And I know this is like a lot to take in, like, oh my gosh, what is going on here? But a lot of times, and you'll notice in this class when I introduce something, it's like, oh my gosh, what are all these words? And it's a little confusing. But after you see an example, once I do one example, I promise you it makes a ton of sense and it's very, very easy. Okay. So here's what we did for this days to maturity. Okay, so I'm going to put this up here for you, and then we're actually going to work one by hand in a little bit. But what they said was they looked at the data and they said, okay, I'm going to group all the 30s together. Okay, so these first numbers here are the lower class limits. So the 30, 40, 50, 60, 70, 80, 90s. So first number is the lower limit. And then the second number is the upper limit. The next thing they have here is they have what's called the class width. So how thick, I don't know if thick is the right word, but what is the width of each class? In all the classes, the class width needs to be the same. For each class or each grouping. And all you do to find the class width, if you look up here, is it says it's the difference between the lower limit of a class and the lower limit of the next higher class. So it's the difference of 40 and 30 is 10. The difference of 50 and 40 is 10. Difference of 60 and 50 is 10, and so on and so on. So the class width here is just 10. This class mark, I'll do this example, this average when we get to our own example, I'll show you how to do this. So all they did is they say, look, how many investments take between 30 and 39 days to mature? There were 3 of them. So they would just go through the data and find those. It's this one, and where's the other one? And this one. Okay, so they just found the 3 that were 30 in the 30s, and that's how they got that one. And then there was one that took between 40 and 49 days, and they got that one. And they did this and so on and so on and so on until they calculated all 40. So then they just got the counts of each, and then they just found the relative frequency. So really all this procedure is doing you just set up the classes. Okay, lower limit and upper limit. And then you count the number of observations in each that fall between. So that fall within the limits. And it's inclusive. What inclusive means is like you take the number 39 and that falls in this group here. So it's inclusive of the endpoints. Does it kind of make sense?
Yes, it does.
Yes.
Okay. I told you it was dry. I tried to warn you. I can hear the enthusiasm. I understand.
Hooray.
Thank you, Robert. All right, so you'll notice someone asked this in the chat, which was great. The homework talks about a histogram. And what a histogram does is it displays the classes of quantitative data on the horizontal axis and the frequencies on the vertical, just like a bar chart. But the big difference between a histogram and a bar chart is the bars should be positioned so they touch each other. Okay, so after you end one bar, you build the bar right after the next one. Okay, you build off of it. And it's because with a histogram, as soon as one group ends, the next group immediately picks up. So as soon as 39 ends, you go right to 40. So it picks right up. That's the subtle difference between the bar chart here. I'm just going back. Like where the Bucks end is very different from where the Chiefs begin. Okay, because the Buccaneer fans are really classy, good group of people. I'm not sure what I can say about the Chief fans. So there's this space between them. Maybe they are. I hope you guys find my, I'm just joking, right? I just try to throw in some dry humor because otherwise, it's very easy to, I hope you love it because, some of my classes have tried to revolt on me. And I said, you know what, I'll go 2 hours without telling a joke. And they were like, at the end of the class, they were like, oh my God, don't ever do that again. So, yeah. So, I like a good bad joke too. Yeah. If I don't tell a joke and I don't get at least 5 to 10 eye rolls a day from my wife, it's not been a good day. So first, I'm gonna more pirate jokes. Yeah, let me just get through these, and then we got 10 minutes left. So actually, what I want to do is I want to skip ahead a little bit. You can see the histograms here for the data from the examples that I have here. These are with the single value groupings. You'll notice the tick marks are in the middle of each histogram. For the limit grouping, you'll notice that the endpoints are at the end of each graph here. So I'm going to let you do that on your own real quick. But what I want to do for the last 11 minutes of class, I just want to get through this one example here, okay, by hand. So you'll notice in the slides, there is nothing there. So I want us to do this just so you'll be ready to do your homework, okay? So sorry to burn through that, but let's do this one example to end class. Okay. So a manufacturer of insulation randomly selects 20 winter days and records the daily high temperature. Okay, so for whatever reason, this manufacturer, maybe they want to know if they're installing too much insulation or too little insulation. Okay, so these are the daily highs of 20 winter days. Okay, so this is a continuous variable, right? Because temperature is a measurement. So what I want to do with this raw set of data is I want to take it and I wanted to put it into a frequency distribution, and then I want to draw the histogram of it. Okay, so if you have a raw set of data, okay, and you want to work with it by hand, what's the first thing you might want to do?
Decide whether it's limited or,
We're going to get to that. We're going to get to that next. You're absolutely right. But what I'm actually going to do is I'm going to order the data.
From smallest to greatest.
Yeah, just so you could just see what it looks like. Okay, so this is what the data looks like from smallest to largest. Okay, so let me ask you this. Do you think we should use single value here or limit grouping, do you think?
Single value.
So the thing about single value is you use that when there's like a, the values are, there's a lot of common numbers, like there were a bunch of ones, there were a bunch of zeros, or there were a bunch of two TVs in households, things like that. So here, I agree with Jamie. I think limit's the best here. Like, what I want to do is like, there's not many repeats. So I want to group like values together. And so you'll notice this when you do your homework. What you want to do is you want to pick something that's easy for you. Okay. So when I look at this data, I don't want to go by, oh, let's have our class width be every 4 degrees or every 5 degrees. When you look at this ordered data, does it make sense to group the teens together, then the 20s, then the 30s, and so on and so on?
yes.
Yep. That's
Yeah,
how I would do it.
Yes.
Mhm.
So what I would do is for my first class, I would say I want all the numbers between 10 and 19. Okay. What would my second class then be, do you think?
20 to 29.
You got it. And what's the next one?
30, 39.
Yep. And then 40 to 49. And then it looks like you need 50 to 59. Okay. Because that gets up all the way to the highest. So then you're just going to count, right? It looks like there are 1, 2, 3 numbers between 10 and 19. There are 1, 2, 3, 4, 5, 6 numbers in the 20s. 1, 2, 3, 4, 5 numbers in the 30s. 1, 2, 3, 4 numbers in the 40s. And then 2 numbers in the 50s. So let's just make sure we added correctly. So 9, 14, 18. Yep. It summed up to 20. So this is good. So then what we're going to do to find the relative frequency of each is we're going to take the frequency and divide it by the total. Okay, so 3 divided by 20, I believe, gets you 0.15. 6 divided by 20, I believe, gets you 0.30. 5 divided by 20, I believe, gets you 0.25. 4 divided by 20, I believe, gets you 0.20. And then 2 divided by 20, which I believe gets you 0.10. So if you were to sum these up, they would all sum to 1. Okay, so that's good. And I apologize for going through it really quickly, but once you figure out the counts in like your classes, it really just kind of like falls into place. And then you're going to get a chance to practice this on your homework this week. Okay, so even though I went through it pretty quickly, does it seem like it's kind of straightforward how to do that?
Yeah,
Yeah.
it is.
Yeah.
Starting to make sense.
Yep. So let me just draw the histogram for this. So now what I want to do is I want to take this and I want to do a visual representation of this. Okay. So let's do, for a histogram, you can either do a frequency or relative frequency histogram. Doesn't matter what you do with your vertical axis or not. Okay, so the way you set up the histogram is you're going to draw the first quadrant of the Cartesian plane. And along the horizontal axis, get your classes. And what your classes are these numbers here. Okay, they're ranges of values. So your first class started at 10. If you're going to do it this way, it's going to start at 10. Where does the next class pick up at?
20.
20. Yeah, so I'm going to put another mark here for 20. And then I'm going to keep doing that. Then the 30s. Then the 40s. And then all the numbers in the 50s. And then I'm going to need an extra class here to go to the 60s. Okay. The reason I have to put that extra class there, all the numbers between 50 and 60 are going to be these counts right here. So then up at the top, what you do is you put the frequency or relative frequency. We'll just do frequency. And it looks like the counts go from all the way from 2 to 6. So I'll just do 1, 2, 3, 4, 5, and 6. So between 10 and what this tick mark here means is under 20. So to 10 to just under 20, it looks like there were 3 of them. So you're going to draw a bar up to 3 like this. And then how many numbers were between 20 and 30? Well, it looks like between 20 and 29, there were 6. So when you build this histogram, you're literally going to build the bar right off the previous one, like that. And then the next one was 5. So when you go to build 5 for the 30s, you're going to build the bar right off. And then there were 4 in the 40s. It looks like this. And then there were 2 in the 50s. Like this. So that's what our histogram looks like this. And notice the big thing here is there's no spaces. Between classes. Okay, that's the big thing here. No spaces between classes. All right. Getting near the end. I'm sorry it was a little dry, but was it maybe not too bad today?
Wasn't bad.
Wasn't the worst. Not terrible. I'll take that.
It was good. I'm waiting for the pirate joke.
I don't have a good pirate joke today, unfortunately. I'm going to stop the recording.